So guys, welcome back. Today we are going to get into section 3. Section 3 of chapter 4 deals with right angle trig, or right triangle trig. So this is actually going to be based a lot off of some old ideas, SOHCAHTOA. So whenever I am given a triangle like so, so here is my right triangle, and there's my angle theta in this corner. We have the opposite side, we have the adjacent side, and we have the hypotenuse. So the opposite is always right across from there. The adjacent is the side next to it, and the hypotenuse is always located across from the right angle. So this gives me the idea of SOHCAHTOA. So sine is opposite over hypotenuse. Cosine, so cosine is adjacent over hypotenuse. And then TOA stands for tangent is opposite over adjacent. So that's the general idea with SOHCAHTOA. So with this, we're not only going to look at these, there are the reciprocals of each of these. So we got the reciprocal of sine is cosecant. Reciprocal of cosine is secant, and reciprocal of tangent is cotangent. So in any given triangle, I know that the sine of an angle, so sine of theta, is always opposite over hypotenuse. I know that cosine of that same angle is adjacent over hypotenuse, and the tangent will be equal to opposite over adjacent. So now I'm going to give you 3 new functions. We're going to have cosecant. So cosecant is CSC. So that's going to be hypotenuse over opposite. Then we'll have secant, which is hypotenuse over adjacent. And then finally we have cotangent, which is adjacent over opposite. We can also state it this way. Cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is also equal to 1 over tangent. So those are all different ways of talking about our 6 different trig functions. So let's look at these a little bit in action. So for our first example, we are going to be given a right triangle. We will not know what the hypotenuse is, so we're going to have to calculate that. And then what we're going to do after we find that, we're going to take that information, a SOHCAHTOA, and apply it into, the sine's this, the cosine's that, and the tangent is this. If I ask for cosecant, all I would do is take the reciprocal of this. So if this was 1 over 4, this would be 4 over 1. And same goes for the other ones. So let's take a look at our first example here. So our first example has a triangle like so. Example 1, Find sine of theta, cosine of theta, and tangent of theta. So over here with this, let's say this is my triangle. Scale does not matter here. Let's say, actually, I'll make it a little better scale-wise to the triangle we are given. Really doesn't matter at the end of the day, but this way it looks a little better. So that's 5 and that's 12. And my theta is located, why did I put an 8 there? Right here. So now that I have this, what I'm going to do is I'm going to take my time. I'm going to first start by utilizing the Pythagorean theorem. So let's utilize the Pythagorean theorem, which remember says a squared plus b squared equals c squared, to find the missing side. So that's going to be 5 squared plus 12 squared is equal to c squared. 5 squared is 25. 12 squared is 144. When I add those together, that gives me 169 is equal to c squared. So I square root and get that this missing side is 13, because square root of 169 is 13. Now that I know these, sine is going to be opposite over adjacent, cosine is going to be, sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. So let's go and look at this. So right away I know my hypotenuse is 13. I know my adjacent side right next to this is 5, so there's my adjacent. And the side opposite the theta is 12. So now all I'm going to do is write each of these as a simple fraction. So sine of theta is equal to my opposite over hypotenuse, so that's 12 over 13. Cosine is equal to my adjacent, which is 5 over my hypotenuse of 13. And tangent is equal to my opposite over adjacent. So that's going to be 12 over 5. Now, quickly going back to the other functions we talked about, I'll show you cosecant is just going to be the reciprocal of sine. So that's 13 over 12. Secant is going to be 13 over 5, the reciprocal of that. And then cotangent will be 5 over 12, the reciprocal of tangent. So that is utilizing a picture you already have to help you with this. Now, in the next part of the notes, there's a big rundown of the unit circle. We've been talking about the unit circle a good bit. You can look at that inside the notes. However, I'm not going to stress every little piece of that, but I will give us a reminder, or we saw that today. We saw how to rationalize today. We're not going to stress that right now. So with tangent, we did see how to rationalize, and we'll see that some in the next section when necessary. So what we're going to do for example 2 is learn how to use a calculator to find these. One thing that is very important, if you're given like, oh, what's the sine or cosine or whatever function of this random angle that is not part of the unit circle, you're going to have to use a calculator for it. It's not a big deal. The big thing to remember when we're utilizing our calculator, if it gives it to you in degrees, please make sure the calculator is in degree mode. If it gives it to you in radians, please make sure the calculator is in radian mode. Otherwise, it won't calculate things correctly. So, let's look at example 2. So, example 2 asks us to find the cosine of, starts out tangent. What is 35.4 degrees. And also wants us to find the cosine of 3.25 degrees. So again, what I'm going to do is utilize my Desmos calculator. So first thing I want to do before I do anything is I need to make sure my calculator is in degree mode. So we're going to hit the little wrench at the top for settings. And then at the bottom, you see radian and degree. Whichever one is highlighted, please click on that to make sure you're in the right mode. So I need to be in degree mode. So yep, I click on degree and that's that. So then I can just go, okay, let's type it in. Go over to my functions. Trig's the first one that pops up. Notice it gives you all your options here. So I'm just going to call it the tangent of 35.4. And there we go. We get 0.7106. Or actually, that 6 will get rounded out to a 7. So let's just copy that down. So that's equal to 0.7107. If you get something else when doing this, most likely is either you typed in the wrong trig function, which I'm doubting that. Most likely you're in radian mode where you're supposed to be in degree mode, so just go in the settings and check that. So the next problem said cosine. So I'm on my keyboard. I'm going to show you. If you just type in cos for cosine, all of a sudden the font changes, so regular font, it realizes that's a common function. So it's going to go, okay, do cosine of that, 3.25. Hit enter, and we get 0.9983. So let's record that answer as well. Again, if you're getting different answers than this, probably means you're in radian mode instead of degree. So just go into the settings and change that. So whenever we're typing angles into the calculator, number one thing, always check what mode your calculator's on. Sometimes if like the app closes down or your calculator like has like a long lull or like resets, sometimes that mode will switch on you without you realizing it. Or if you're borrowing a calculator, say from school, you'll always want to double check it because you don't know what mode the last person was using. So, already went over the reciprocals. We can see those in the notes. There are 3 important Pythagorean identities. I'm just going to give them to you verbally right now. We're not going to stress about them because I don't think there's anything in your homework. No, nothing in your homework that requires them. So, what we're going to do, Pythagorean identities. Sine squared plus cosine squared is equal to 1. We actually get that from the unit circle itself, because you got the one side here, that's your cosine, this side coming up this way, that's sine, and your hypotenuse we know is 1. So cosine squared plus sine squared is equal to your hypotenuse squared of 1. 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. Those are a little less common trig identities that we use. So, oftentimes we'll have to find missing information. So I'm going to give you an example of finding the height of a tree when we know the angle of elevation we are looking from. So this is just going to be one last application problem, and we'll go from there. So, example 3. So here, a surveyor is 50 feet from the base of the tree. So 50 feet from the base of the tree. And he is looking up at a 75-degree angle. So he has this little measuring tool, and he found, as he's looking up, the measurement of his looking up is 71.5 degrees. So angle of elevation, let me make sure, yep, elevation is 71.5 degrees. So we're going to utilize what we just did. We're going to draw a picture of this, see what pieces of information we have, see what pieces of information we need, and go from there in solving. So with this, I'm going to have this brighter red marker. Let's use that. Have a tree over here. Your picture does not have to be great. As you can see, I'm not much of an artist, but that's okay. Got my little stick figure guy over here. I know he's looking up at a 71.5 degree angle, and I know it's 50 feet right here. So what I'm going to do is realize I want the height of the tree. So the height of the tree, I'm going to call that X. That is opposite of where I'm looking. So that's my opposite side. The ground is right next to me. That is my adjacent side. So I realize if I'm dealing with opposite and adjacent, I need to utilize tangent here. So I'm going to say the tangent of 71.5 degrees is equal to my opposite, X, over my adjacent of 50. Well, I realized to finish solving this, let's multiply both sides by 50. So those cancel out, and we're going to do 50 times tangent of 71.5. That's purely in the calculator. So, just to confirm, yes, I am still in degree mode, but you can always hit the settings to make sure. So I need to do 50 times, and the function is tangent of 71.5. Not 1.5. 71.5. And I get that the tree is about 100, close to 150 feet tall. I'm just going to round it off at 2 decimal places because that seems like accurate enough. So 49.43 feet is my measurement. So let's just record that. So X equals 49.43 feet. And if we think about that, that's close to about 100 yards. So the length from end zone to end zone of a football field about. 150. It's about 50 yards. Sorry, I was thinking about 300 for some reason. It's about 50 yards, so that's about half a football field. And to say a tree is as tall as half a football field, yeah, that seems reasonable to me. That seems like a reasonable measurement for a tree. So You know, it's definitely a tall tree, but not an unreasonable number. So thank you guys for tuning in. The work will be posted with this along with the notes, so please make sure you get that done. Thank you and have a great day.